Today we're going to be talking about solving quadratic equations using the quadratic formula. Now, why the quadratic formula works is a bit beyond the scope of this video, but if you do want to click on the textbook reading, the first thing they go over is a really nice derivation of the quadratic formula using completing the square. If it is something you're interested in, I do encourage you to check it out. It is very nice proof. But otherwise, if you're like, I want to know how to practically use the quadratic formula, then this is the video for you. First thing you're going to have to do is learn the quadratic formula. In terms of algebra, it is actually the most complicated formula that you're going to have to learn by heart. And let's go over at least how I still sing it in my head to this day. So you're going to remember that the solutions, once you have your quadratic equation rearranged so that it's set equal to 0, is that x is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Sing that in your head, you're good to go. If you want a little bit more beautiful singing, I encourage you to find other videos on YouTube that have the exact same thing. Otherwise, that's exactly what the quadratic formula is, and I would first just write it down as is initially. Now, what this note is about the number of solutions is that if the number underneath the square root ends up simplifying to some sort of number that is bigger than 0, then you're going to end up with 2 solutions. If the square root itself ends up simplifying to 0 itself, you're going to wind up with 1 solution. If we have a negative underneath that square root, then there are no real solutions, and you just want to stop the solving there and talk about that there's no real solutions. So let's go ahead and look at some examples of this. If you're going to be using the quadratic formula, you basically want it to not be easily solvable by one of the other methods that we mentioned. Now, completing the square and quadratic formula are probably roughly equally easy for a lot of problems, but especially if the b over 2 squared gets a little bit unwieldy, sometimes quadratic formula can be a bit more straightforward. But if you can factor or just do the square root property, you want to do that instead. And actually, this first example is an example that actually is factorable, but we're going to solve it with the quadratic formula anyway, just for illustration. So the first thing you want to do is write down your beautiful formula. So x is the opposite of b plus or minus the square root b squared minus 4ac all over 2a. And then you want to note exactly what those are. So a is the coefficient in front of x squared, in this case secretly 1. B is the full coefficient in front of x, which in this case is -6, and c is your constant, which in this case is 5. Then you're going to want to very carefully plug it in. So x is the opposite of b, so that becomes positive 6, plus or minus the square root of b squared minus 4ac all over 2a. Then when it comes to simplification, tackle what's underneath the square root first. So we have 6 plus or minus. Within that square root, we have -6 all squared, gives us 36. 4 times 1 times 5 gets us minus 20 there. And then 2 times 1 is 2. Keep on going. 6 plus or minus 36 minus 20 will give us 16. And then if we want to keep on simplifying, the square root of 16 is 4. And then this is a case where it's actually just going to simplify really nicely into 2 actual solutions, or 2 rational solutions, I should say. This is going to be actual solutions both times. So we'll have 6 plus 4 over 2 as one of our solutions, and 6 minus 4 over 2 is the other solution. 6 plus 4 over 2 becomes 10 over 2, which is 5. 6 minus 4 over 2 becomes 2 over 2, which is 1. And so our final solutions are that x is equal to 5 and 1. Now, if you notice, that was actually a lot more work than factoring from the get-go. So this is a good illustration that if you can factor, you really just want to factor because it's going to be a lot less work. And again, this is just reiterating that that's really your steps here. So let's go ahead and continue to practice the quadratic formula here. So first thing you're going to do is write down that this is x is the opposite of b plus or minus the square root b squared minus 4ac all over 2a. And then note exactly what a, b, and c are. In this case, a is 4, b is -8, c is 2. And then you're going to start to plug in. So x is the opposite of b, 8 plus or minus the square root of b squared minus 4ac all over 2a. Then you want to keep on going, tackling what's underneath the square root first, because in terms of order of operations, that's basically a giant parentheses. -8 all squared is 64. 4 times 4 times 2 becomes, what is that, 72-ish? I'm actually blanking a little bit. No, that's too big. No, it's going to be like 32, right? 32, yeah. Minus 32. All over 8. Then we have 8 plus or minus 64 minus 32 leaves you with 32 over 8. Then we're going to want to simplify the square root of 32. It's not a perfect square, but he does simplify. So in particular, the square root of 32, we're going to break down 32 into 16 times 2, exactly what we multiplied to get there. 16 breaks down to 4 times 4. That's already our perfect square. So we get 8 plus or minus the square root of 4 squared times the square root of 2 all over 8. Square root of 4 squared becomes 4. And then we want to notice that if 4 goes into each of these coefficients, we are good to go ahead and divide all 3 of them by 4. Notice how we have to divide all 3 and we don't actually attack what's underneath the square root. What's underneath the square root is like a unit. We're going to leave it as is. 8 divided by 4 gives us 2. 4 divided by 4 gives us 1, so we just have plus or minus root 2. And then 8 divided by 4 is 2. So 2 plus or minus root 2 over 2 are our solutions. Keep in mind that literally means one of them is 2 plus root 2 over 2. And then one of them is 2 minus root 2 over 2. So that is talking about 2 literal solutions. So I'm going to go ahead and pause, and I'm going to encourage you to go ahead and try these next two yourself, and then we'll talk through them together. So for this next one, again, you want to write down your quadratic formula first. So x is the opposite of b plus or minus the square root b squared minus 4ac all over 2a. And then notice what a, b, and c are. So a is 1, b is -1, c is 4. So opposite of b becomes +1 plus or minus the square root of b squared. So that's -1 all squared minus 4 times a times c all over 2 times a. 1 plus or minus the square root of, tackle underneath the root, 1 minus 16 over 2. 1 plus or minus, that becomes the square root of -15. And then you want to pause from here because you notice that that's a negative underneath the root. So since we have a negative under the square root, that means there are no real solutions, I should say. There's technically complex solutions, but that is beyond the scope of this video or practice exercises. So that one has no real solutions. And then for the next one, we want to go ahead and do the same thing. Now for this next one, you might notice initially, oh, it appears that 4 goes into all of these numbers. Am I actually allowed to go ahead and just divide everybody by 4? You are. And that's actually something we could have done to make our life a little bit easier in this first one, is we could have divided everybody by 2 from the get-go. So I'm actually going to go ahead and do that here because I'm noticing if I do b squared, that's going to be a little bit messy. So I'm actually going to divide everybody by, and I'm even going to divide them all by -4. So that gives us, oh, that does not cancel out. Why did I just draw that? So -20 divided by -4 gives us +5x squared, and +24x divided by -4 gets us -6x. -4 divided by -4 gives us +1, equaling 0 divided by -4 is just 0. And again, we're also going to pretend that we're not going to notice that this is factorable. We're just going to factor in by the quadratic formula. Which really the previous two were good examples of where he was not factorable and you'd have to either use quadratic formula or complete in the square. Here again, we're just going to do it for practice. So x is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And then we're going to actually note what those are. So a is 5, b is -6, c is 1. So opposite of b would become +6. In these cases, b has been consistently negative, but had b been positive, I would have written a -6. Square root of b squared minus 4ac 4c all over 2a. And then we want to keep on going. So we want to tackle what's underneath the root first. So 6 plus or minus, that would become 36 minus 20 all over 10. 36 minus 20 is going to get us 16. Square root of 16 is 4. And now we can split that into our two solutions. One's going to be 6 plus 4 over 10. One's going to be 6 minus 4 over 10. 6 plus 4 over 10 gets us 10 over 10, which is just 1. 6 minus 4 over 10 gets us 2/10, which is 1/5. So our two solutions are going to be 1/5 and 1. So in short, what do you have to do? You first need to rearrange this so that it's set equal to 0 if it wasn't already. These consistently were, but if they weren't, you would need to set it equal to 0. Then you want to write down your quadratic formula exactly as is. X is the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Then you want to note what is a, what is b, what is c. Then you want to carefully plug in for a, b, and c. Then you want to simplify underneath the square root first, as much as you can, and then you want to split this into your two solutions, one that will be plus the square root simplified and one that will be minus the square root simplified. If what is underneath the square root is itself a negative, then you're going to want to note that there is no solution if it's negative after you're done simplifying. Otherwise, you're just going to write down your potentially two solutions, and in the case that that square root simplifies to 0, then you're really just going to end up with one solution because there is nothing to plus or minus.